test y equals x to the fourth minus 2x squared for each type of symmetry. Then check the graph using Desmos. So we have three types of symmetry that we need to check with each of these problems. The first is symmetry with respect to the y-axis. And remember, the test for that is to replace x with negative x and see if the new equation is equivalent to the original one. So let's do that. If we replace x with negative x, that's going to be negative x to the fourth minus 2 times negative x squared. Now, when we have a negative raised to an even power, that's going to end up being a positive. So this is going to be a positive x to the fourth, because we've got a negative times a negative times a negative times a negative, and the first two negatives and the last two negatives cancel. Then we've got minus 2 times, and again, a negative times a negative is going to be a positive, so we've got minus 2x squared, and this is equivalent to the original equation, so we know that we have symmetry with respect to the y-axis. Just going to highlight that so that we're keeping track of which symmetries we have. Now, let's look at the next type of symmetry. This is with respect to the x-axis. And to check this, what we need to do is we need to replace y with negative y. When we do that, this gives us negative y equals x to the fourth minus 2x squared. And here, if we want to get y alone so that the left-hand sides match up, we can divide both sides by negative 1. And if we do that, this gives us y equals negative x to the fourth plus 2x squared. This does not match with the original equation. They are not equivalent, so there is not symmetry with respect to the x-axis. Now, the third type of symmetry we need to test is with respect to the origin. And the test here is to replace both. Specifically, we replace x with negative x and y with negative y. When we do that, that gives us negative y equals negative x to the fourth minus 2 times negative x squared. Now, we've already seen this right-hand side before. We know that the negatives inside the parentheses go away, and so we've got x to the fourth minus 2x squared, and we've got negative y on the left. But this is the same as the equation we had in the last one, and we already saw that that was not equivalent to the original one, because when we divide both sides by negative 1 to turn that into a positive y, this becomes a negative x to the fourth, and this becomes a positive 2x squared. So again, we end up in a situation where this is not correct. So the only type of symmetry we have is symmetry with respect to the y-axis. So I'm going to box that in as my final answer. Now, you can go to www.desmos.com and you can enter this equation in to see what the graph looks like without going through the trouble of making a table of values on your own. And if you do that, you should get something like this. This is the graph of y equals x to the fourth minus 2x squared. And if we talk about symmetry with respect to the y-axis, we can see that that symmetry does exist. Any point that we have on one side has a corresponding mirror image point on the other side of the axis that same distance away. It's true for any point on one side. Not that I drew those perfectly. But because of this, we can verify visually that this graph has symmetry about the y-axis. Just a quick note, another use of having these types of symmetry is that if we didn't have a graphing calculator and we wanted to graph this by hand, instead of making a table of values that had positive values and negative values, we could just use positive values and get several points, and we could use the fact that we know it's symmetric about the y-axis to then plot the corresponding points on the left-hand side. This cuts down on the work that we need to do in our table of values, because each point that we get on the graph on the right-hand side will also give us a corresponding point on the left-hand side. So even though we're just trying to get a little bit of comfortability with symmetry, I just want you to know that there are ways in the future in which symmetry can be a very valuable tool for learning something about a graph.